Lighting up lives is the primary goal of an electrical engineer. In today's modern world, delivering this masterpiece in uplifting livelihoods is the biggest promise that an electrical engineer can deliver. Engineer. How is it defined? He is a person who designs, builds, or maintains your surroundings to make sure your living standards are maintained. EMTV on its inaugural video feature had this unique opportunity to pay a visit to a personality who has engaged himself in lighting up lives in form of his electrical engineering expertise in the past 40 years. He is the chairman of the Institute of Engineers Malaysia Southern Branch, the managing director of Channel Care Sendirian Berhad, a board director of Panaran Sendirian Berhad. While immensely contributing to many engineering faculties and associations in building up the next generation of engineers, he also serves in many charity and non-governmental organizations in serving the community. Engineer Thayala, R. Selvaduray, thank you for your time.
Thank you for the invitation. A brief introduction of myself, what made me what I am today. As an electrical engineer, having spent over 40 years and still a practicing engineer, it's a blessing I kept in this profession and not deviating as many do. First, my appreciation to those who have been part of my journey. Not forgetting my late parents who educated and instilled humble values in me. My brothers and sisters who were around to navigate me in my teen years. My teachers who shaped me, especially my primary school teachers. I still keep in touch with them, especially my primary 1 school teacher, who is now over 85 years. My philosophy was to do what you like and do it well. Learn to accept that everything happens for a good reason. My dad worked in the plantation industry and I did my primary education at Sulaiman School, Bentong, Pahang. At primary 6, I was elected as the school captain. My parents and a teacher advised I should continue my studies in Kuala Lumpur, where there were greater challenges awaiting me. True enough, it was. Started my lower secondary in LaSalle Brickfields, staying with relatives, and became more independent. No tuitions then made my mind wander. Took part in the first Malaysian Scout Jamboree in 1966 in Penang. Only representative from the school. Met fellow scouts from other states and also from Thailand, Australia, New Zealand, Nepal. Looking back, these experiences were my foundation to what I am today. Started hitchhiking at the age of 14 from Kuala Lumpur to Bentong, 48 kilometers, to save the bus fare of Malaysian ringgit 1 ringgit and 95 cents, and also explore myself. My guardian and my parents were unaware in the beginning of my hitchhiking. At LaSalle Brickfields, represented the school and stayed in athletics. State champion in Selangor in the 4x100 meters and had over 14 gold medals in inter-school relays in 1 year. Went on to continue my secondary Form 4 and Form 5 in Victoria Institution in the year 1969 and 1970. A great place to study, a dream for many, developed discipline and character building. The headmaster started a junior hostel and I was the first person to register. It was like the hostel started because of my needs. In 1971, went for my further studies doing engineering diploma at the South East London Technical College and a degree at the City University of London. A great place to learn living skills and establishing network. Had a choice either to return to Malaysia or stay in the UK. Was given a PR in 1978. Did an analysis and found Malaysia had the second most number of foreign students in the UK Assuming if most of them returned back to Malaysia, and with the vision of 2020 then, Malaysia was set to be one of the best places to work. So I took the challenge to come back to Malaysia. Worked in National Semiconductor in Penang for a short period before moving to Johor Bahru in 1978, where my analysis was to move to the growth hub, being close to Singapore. Got used to the laid back in Johor Bahru and the style and life in Johor Bahru, and have been here in Johor Bahru since 1978. Had temptations to move to Australia after getting married since I had a PR. Still had hopes that Malaysia would be a developed country. The rest is history. Worked in the shipyard, Malaysia Shipyard and Engineering, now renamed MMHE. Had great engineering opportunities to learn and travel. Exposed to ship repairs, later shipbuilding and oil and gas platform fabrication. My achievement there was involved in the construction of two numbers of 75-meter offshore patrol vessel called the OPV for the Malaysian Navy, from the design to commissioning and warranty guarantee. This was a great exposure to me, having understood the whole concept of A to Z of engineering. During this period, had an offer to work in Petronas, accepted the offer and later rejected it, as was so passionate with the progress of the OPV. Moved to Saim Sembawang in Pasir Gudang, who were the leaders in oil and gas fabrication platform. A great shift in work culture compared to MMHE. The workload was sort of tripled. My achievement there was I was a prime mover in the company's direction towards achieving the Prime Minister's Quality Award in 1995. We achieved it. Moved to CCM Chemicals in Pasir Gudang, a great shift from fabrication to production. Being a CMA site, a major hazard industry, had to be ahead and manage any potential environment, disposal, safety, handling, storage, process, and other many problems. The challenge is you need to be vigilant. I had to provide electrical support 24/7, and this took the toll in me, my family, and my social hours. My achievements here was hands-on electrical and instrumentation, learning from design, engineering, operation and maintenance. With exposure, got my professional engineer license, competent engineer license, energy manager license, had radiation protection officer license, and ISO 9001 quality management representative, which became invalid after I left. In 2010, appointed as director for Panoron Sdn Bhd and managing director for Channel Care Sdn Bhd and Megalian Sdn Bhd. With over 30 years of experience, the next phase was either to retire or to take on more challenges. I took the latter by using the licenses to serve the industries, currently serving 35 over industries in electrical compliance and energy management. Must thank the years of experience which has assisted me to advise clients. There's no substitute for experience or hard work. Having been active with the Institute of Engineers Southern Branch, IEM-SV, since 2010, I was the interviewer for electrical engineers to become professional engineers. Later as Vice Chairman in 2020 and Chairman in 2022. Having been equally active in NGO-related work, example, EWRF-JB is called Educational Welfare Research Foundation Johor Bahru, JIBA, Johor Indian Business Association, IEM, Institute of Engineers Malaysia, Parent Teachers Association, and Board of Governors. In EWRF Johor Bahru, I was one of the founding members in 1988. EWRF Johor Bahru is an education-related NGO related to socio-economic upliftment of the community. JIBA, a business organization which came out of necessity in the year 2001, and I was also part of the founding member. Engineering Institution of Malaysia is the premier institution for all engineers in Malaysia. As a recognition of my social economic commitment and upliftment, I was awarded the Pingak Ismail Sultan called PIS by the Sultan of Johor in 2007 and the Iskandar Malaysia Social Hero Award in 2016. As part of my socio-economic upliftment of the community, I was involved with schools, many schools in the state of Johor. And being in Johor Bahru, we wanted to do an iconic project in Johor Bahru. So a few of us got together, had some chat with the headmaster and the school management. So it's about time the school had a hall not only for the school, but also for the community to use for educational related activities. And surprisingly, the response was very positive from the headmaster then. So we formed a working group and we demolished a recreation playground and we built a school hall, 6,000 square feet of place, and we managed to complete it. It was a feat I couldn't imagine I could take it on, but because we had a team, we were able to put up the hall. And today the hall is a very prestigious building for the school. They use it for many activities, and this is something I feel very glad that I've contributed something in society. In 2010, in the resident community where I stayed, we got together to do a major project. This major project was a need which all residents were looking forward to. A gated and guarded community. This area being in the city area, we had a number of issues. Right? Basically, petty crime was number one. And as engineers, I always believe we can do it. And fortunately, in the neighborhood where I stay, we had 3 professional engineers, we had lawyers, accountants, doctors, all. So we sat down and brainstormed what we can do. We engaged the local politician as well to come and assist us. This area is a very it's about 1965 resident community, so a lot of things were not in place as a decent housing estate. We had to create something which wasn't allowed in the local authority. We got in touch with the local council and the political leaders in the neighborhood and discussed with them how we can make it more safer for the residents. Surprisingly, the political leaders were very supportive and they gave us a green light to go ahead. But the local authorities were not, because it is not in their bylaws to allow housing estates which are old ones to have their own gated or guarded system. But we went ahead positively. We had a lot of interference from the government, but fortunately we had support from the political party and we managed to build up a good gated and guarded system. Today it is a place where we feel that we have secured the environment. My primary focus now is towards the Institute of Engineers Southern Branch, where I'm the chairman, and a committee of 10 with over 650 professional engineers and a total of 4,800 members in Johor and Singapore. In Malaysia, IEM has a membership strength of over 47,000 members. Our aim is to make engineers better engineers. Our responsibilities include continuous professional development, interviewing engineers to be professional engineers, dialogue with regulatory bodies, meeting with local authorities and government agencies. In conclusion, Malaysia is a blessed country and we have to ensure we maintain the high standards towards environment, racial harmony, political stability, safety, health, education and security. If only we can respect and work together, will we rise again. To those wanting a career in engineering, having been involved in electrical engineering and associated with all the other relevant engineering disciplines, strongly recommend to take engineering as a career. If you want more contact, our IEM Southern Branch office telephone number 07 331 9705 will be able to assist, or they may guide you to the right person. The first 5 to 10 years of your engineering job involves getting hands-on experience at your work site. There's no substitute, hard work. Once your experience is acquired, seek for different types of experience. There's no substitute. Looking forward for more engineers to take management role in multinational companies. Together we can. I would like to add on a few more experiences which I have come across in my studies. When I did my engineering degree in 1972, 72, there were no calculators, there were no handphones, there were no computers. We had to start with log tables, LOG tables. Now you may have never heard of it. So if you want to calculate angles for your calculation, you got to use log table. Later came this thing. It's so new that you may wonder, did I use it in my studies? I did. This is called the slide rule. Right? You can move around. You got all the numbers here. X cube, you got arctan, you got arcsine, you got square root of 1 minus x squared and all that, which before this we were using log tables, and now we use slide rules. This was my early days, my first year, my second year in degree, I was using this. Then came this new gadget called calculator. So we're all trying to look at calculators. I invested in this calculator. This is probably one of the first calculators, miniaturized calculators for students' use. This is called the Sinclair calculator, scientific calculator. It works still, it works. I just have to change the battery and it works. But it doesn't work like a normal calculator, but it does calculate whatever you want. Then, as technology progressed, they came up with another calculator which is more scientific, and this calculator I had to use in my fourth year, my final year. So that's how I grew up. So I was lucky in my generation. I was able to witness analog, digital, Wi-Fi. Now we are into clouds. In the 30-40 years of my life in engineering, I've seen this. The next 30-40 years of your life, if you're a young engineer, you will witness more challenges. Take on the challenge, welcome positive change, move on, and make humanity a better place. Thank you.
Engineer Thayala was so kind to take us to a project site among many other projects he has delivered to explain the electrical engineering masterpiece.
Hi, good day to you. I would like to take this opportunity to share about electrical high voltage switchboard, switchgear, generator and transformer. These are areas where not many people get access to. This room is normally locked. It can only be entered by authorized people. This room is a 33,000 volt room. They call it 33 kV in short. What you see here, there are two panels here. This panel here and this panel here. This is for a condominium, and it's called the management supply. You can see this way called management supply, right? Going out to two different outlets, two different transformers. And over here is the tenant. You can see here it's written tenant here, right? Tenant supply. So the tenant supply has got 1, 2, 3, 4 transformers going to 4 different areas of the building. And it's important that these things function as per design, as per safety requirements. Now I'm going to take some readings here. I'm going to use Google Drive. This is one of the best ways for me at the moment. I use Google Drive to take my readings, and then later my staff will follow up on that. Now I'm going to take the readings on the management supply and later on the tenant supply. So these two readings will tell me what sort of consumption is going. On top of that, I also have got to look at the gas here, called SF6, which are very important inert gases for quenching any internal arcs. Then I got to look at all the safety features are functioning, the calibration dates are functioning, the the backup protection batteries are also functioning, and also the remote supply here. You see here you got the remote switching and switching on and switching off, remote control panel for the utility supply management, and remote supply for the tenant. So these are all supposed to be working. You got the supply fan, and you also got on top of that, you can see is the fire curtain for carbon dioxide, fire curtain, and you can see the carbon dioxide systems are here. Right? These are the carbon dioxide supply, so it's very important these things all work in tandem, and my job here is on a monthly basis. I come here twice to make sure these things all function safely and give them a certificate of operation. Hi, what I showed you earlier was 33 kV switchgear room. There are two incomers there. One is for the management and the other one is for the tenant. The management has two transformers. The two transformers are located inside here, and the tenant has four transformers. The four transformers are located here. The incoming is 33,000 volts and the outgoing of these transformers are 4 and 5 volts. From there they'll go to the switchboard for distribution to the respective area. Let's go inside. So what you see here is 6 transformers. They work 24/7, and technically speaking you can isolate some of these transformers to save some energy. So you have got 6 transformers. Should we use all 6 transformers? If you notice in the power supply during the current is very low. When the current is very low, the transformers are not delivering as it's designed for. So I would recommend for the management to sort of couple the transformers, couple the switchboards and isolate the transformers. That way you can save, because these transformers are running 24/7 and there are losses. There are losses in the transformers. This could be easily saved. Follow me please. Okay, what you see here, let me do step by step. This is the management. Management takes care of the emergency systems, the swimming pool, the corridors, the lifts, the firefighting pumps, the water pump, all necessary other than tenants is taken care by the management supply. The management supply has a 33 kV supply. You call it here 33 kV Tenaga Nasional incoming supply. They go in, and of course all the safety circuits are here. Then they go down to 33 kV down on the bus bar to the to the transformers. There are 2 transformers here which you saw just now. 2 transformers. From there they are stepped down from 33 kV to 433 volts, and they are then distributed to the distribution boards for the management controls. And then similarly, this is also a different set of supply for the tenant. You can see here tenant, right? The tenant supply is here, and the TNB supply comes here 33 kV with the protection circuits here, going out to 4 transformers. In other words, going to different blocks. Tower 1 is here and Tower 2 is here. Right? Again, Tower 1 and Tower 2 is also split in different areas. So you got the transformer here, step down from 33 kV to 433, going through breakers and then going out to the switchboard rooms, the main switchboard room, which I'll show you later. Likewise, the other 2 transformers also same thing. They're going to Tower 2, they're broken down into 433 volts to the main switchboard. Thank you. Hi, let me take you to this important area called emergency power supply. This emergency supply for this building comes from a generator, and generators are automatically set to operate when there's a power failure. Let's walk in and see how it looks like, and maybe I'll try to explain to you a few things here and there. Okay, you see a huge generator, yeah? This generator is in the nameplate here, it shows in terms of capacity, this generator is 1550 kVA. Yeah? You can see here 1550 kVA. That's quite a big generator for a building like this. And the whole system works like this. You have got a panel here. This panel here monitors the power supply coming from the utility company, and in unlikely situation, if there's a voltage drop, a sensor picks it up and it's set on auto at the moment. It's set on auto here. If you look at this here, auto. So when it's set on auto, whenever there is a power dip after a certain amount of time, for example maybe 10 seconds or more, 30 seconds, depending on how you want to set it, immediately this thing will cut in and the generator will start. And the moment the signal for the generator starts, within 5 to 10 seconds the generator is at full speed, and immediately the whole supply comes in. So in other words, an interruption will be only about maximum 10 seconds, right? It all depends how you want to set it, but it's about 10 seconds. Now this battery here is a battery to help start the generator. This generator, there's 2 parts. This is the main engine, or we call it the prime mover, right, which drives the alternator. Alternator is the one which gives the electricity. If you want more details, you can just type alternator and find in the what do you call it, in internet. And there you got a generator running and giving out power supply. It's our power supply, and it goes to various places in the building. The switchboard, there's some switchboards which take the power supply and supply to the building. The intake is here, and then this is the exhaust you see outside there. The exhaust is this one. So you can see the exhaust of the engine is shown out. Very important, the exhaust and the entry of the air, fresh air must be at different location, otherwise there will be recirculation. Hi, let me also take this opportunity to share with you about the firefighting system in a typical electrical room. This is a panel which is located outside the door. It's supposed to say everything is healthy. So you see here green light, that means it's okay. The voltage must be stable above 24 volts, and the battery must be on charge mode, and there's no alarms here. What you see up here is a smoke detector. In an unlikely situation of a fire, of course smoke will be there first, so that is being picked up. Now, to energize the alarm, it doesn't activate just on one sensor, it has to have more than one sensor, in this case 2 sensors, to ensure that it's really a smoke and not a false alarm. So I'll take you to the other one, which is called the, you see that white dome now? That's the heat sensor. So when it gets hot, a temperature is set to it, and then that will activate. So in the situation where a smoke is picked up and heat is picked up, that means it's genuine. If it's genuine, an alarm is sent to the panel I showed you earlier. They call it fire alarm panel, and within about 30 seconds alarm will ring. When the alarm rings, it's telling that it's going to activate the CO2 bottles. When the CO2 bottle activates, no one should be in the room. These are the CO2 bottles. What happens is the signal comes from the alarm panel, comes in here, electrical supply. Electrical supply comes to the alarm panel through this wire here, and energizes the solenoid here. Once the solenoid is energized, there's nitrogen gas here. The nitrogen gas is pumped into here, activated here, and this lever is opened. Once this lever is opened, carbon dioxide from this red color cylinders are activated into the main line and goes up and sprays the room with carbon dioxide. It's very cloudish, and one by one the same pylon cylinder will go and activate the next and the next and the next. All of them will energize, and the gas is out there, and within 30 seconds plus you will have all this room filled up with white color smoke. No one can see each other, and there's no oxygen in the room. So if you are in this room, it's considered you're very unlucky in an unlikely situation. Now when that happens, you have to make sure all air ventilations are closed. When you see up here, the air ventilation, right? This is air ventilation for the exhaust. This curtain here will immediately drop. In other words, suffocating this room with oxygen. When the room is suffocated with oxygen, that means there's no other way of fire being surviving. So the carbon dioxide will suffocate the fire. That's how it works.